The measuring G of a piece of card is actually quite an interesting one. It's a good practical for many reasons, not necessarily for getting the result. It's very easy to set up to make a prediction with it when you don't include resistance. However, if you drop card through a light gate, what you're in essence doing is you're dropping something that's very flexible. You can get a reading, yes, but the card will flex on its way down. So what I do is I tell the students that they can change the height at which a card is dropped from, and then obviously they have to make sure the same distance actually goes through the light gate, otherwise the problem is not a valid experiment. They can change the amount of cards, they can cut it, and there are different ways of doing this. It's a really cool experiment because actually if you leave a range of cards and things out, they have to work out what ones will give the best data. So they're looking for how to get the most valid results, knowing that the more flexible it is, the more it will flex as it falls through the air, but the firmer it is, usually the heavier it is, and therefore you're changing the forces quite considerably. So there isn't really a right answer, it's just that it's a really good design or a good challenge, and seeing who gets close to the G at the end is very nice. The only other thing that you need to remember to this, particularly if you're using the software I use, and it probably is the same for most, is to make sure that you've set up some form of distance measurement. So in the software I use, you would have to measure the length of the paper and say this is however many centimetres, just so it's got so it can give you an answer in metres per second squared. Other than that, really simple, really straightforward, rarely gives good answers, but it's fantastic for talking about validity, for talking about perfecting experiments, for iterating ideas and designs. Really, really good.